Physics, University of Dar es Salaam. The first two lectures were given at COSTECH and at the Open University of Dar es Salaam. The Open University of Tanzania, sorry. All these lectures were given and is going to be given today as well by experienced astronomist Dr. Gordon MacLeod.
Hello. Yes, you can hear me. I'm not used to speakers like this, so firstly, let me try to speak slowly, pole. I speak very fast when I get excited, and I will try to speak slowly. So remind me, please. Okay? Firstly, let me say this. I do come from a rather eclectic background. I was an astronomer, researcher, and then I left astronomy and I ran businesses for several years, and then I went back into astronomy. And each of those stories is a story in itself, and I'm not going to tell those today. But what I can say is that my experiences in business and in research has actually led me to where we are here today. And part of it my journey actually started a very long time ago. In fact, only a few months after I was born. This is not it, but I will do this first. Let me talk about the brief history of astronomy in Africa. And this will have some feel for this. A lot of the observatories, a lot of astronomy was originally optical, pure and simple. Okay, so people looked through telescopes, as did Galileo, people like that. And they needed, for navigation purposes, of course, you needed to have observatories in the southern Cape, in Cape Town, and likewise up in Egypt. And there were other observatories around the continent, of course. These are just two that I mentioned. But effectively, they were used for setting time. So you would put an observatory on top of a hill, and you would drop a cannon. And then the people in the ship would actually see the cannon fall, and they know it's 12 noon, they set their clock, and now they know how to navigate around the oceans. Okay? So that was the real drive for astronomy, probably 200 years ago, okay, around the 1800s and stuff like this. And largely it was the way the English Empire was able to expand around the world and to colonize people in Africa and South America. And the word colonize is the wrong word, we know, okay? Because it's never friendly when somebody comes into your country and takes your land. So let's not use the word colonize, but that's what they would say. But astronomy has its history largely in that, and even older than that, of course. You know, there's a site in southern Egypt called Nabda Playa, which is probably the oldest continuously used astronomical site in the world, even older than Stonehenge, most likely, where they used the stones in a circle to determine when to plant crops, when to expect the floods in the Nile Valley and stuff like that. And that's the beginning of astronomy. It really began probably in Mesopotamia and in the Egyptian Nile area, and then astronomy expanded around the world. And as I said, this is the more recent history of astronomy, where they built observatories such as SAO in Cape Town and the one in Egypt, in Alexandria, Cairo. Okay? More recently, radio astronomy is very young. Radio astronomy only started in 1936. A young engineer named Karl Jansky was tasked to determine what was making the hiss in transatlantic phone calls in the 1930s. So he set up a very small antenna. It basically looks like a lot of your old antennas you have that people used to use in the old days, like the bunny ears. Remember the bunny ears on your TV? Did we have those? No? No bunny ears, okay. But I mean, they were just basically antennas with these long wires, and they could rotate them. And he had one of those, and he rotated it around, and he found that the signal that was causing the hiss was actually astronomical. He realized that it was rising 4 minutes earlier every day, and the stars in the sky rise 4 minutes earlier every day. And that's the difference between our clock that we read, we tell what time it is, versus the sidereal rate of the stars. So effectively, this guy, Karl Jansky, he was a young electrical engineer, he wrote this up, he realized it was astronomical, he wrote a paper on it, he sent it to the optical astronomers, the Astronomy Journal of the United States, and they rejected it. They said, there's no such thing as radio astronomy. So one of the important points of that is that, you know, like a lot of people, even though we think we're very open-minded, you would imagine astronomers are very, you know, they're looking into the stars, they're looking into the universe, they should be very open-minded people. In fact, they're not. They're the opposite. So the scientific method, for example, I will make no bones about this. I actually don't believe the scientific method works. Because if you want quantum leaps of knowledge, if you want to come up with new concepts and new ideas, if you follow the scientific method, you will only make very small incremental steps. Because you have to make a proposal, you have to think about a hypothesis, figure out an experiment to test the hypothesis, get your results, and then finally write your conclusions. If you do not do that, journals around the world will not publish because they will not accept your work. But the reality is, the biggest scientific discoveries in the world did not happen incrementally. They happened in quantum leaps of faith. I mean, even Isaac Newton, I love this story about Isaac Newton. He grew up at the time of, King Henry VIII and people like that in the 1600s. And at a time when, he became a professor, and some of you, how many of you are professors here? How many of you are professors at the university? A couple of you, right? Okay. Now, if you were a professor in Cambridge in the 1600s, you would have no teaching. No teaching. Professors in the 1600s, and Isaac Newton was made a professor at 16 or 18 years of age, very young man, and he had his students teaching. So only students taught other students. Professors, they just taught. But in fact, Isaac Newton spent most of his life in committee meetings, determining how to improve the food at the local university, and sleeping accommodations and whatnot. Poor Isaac Newton worked out that he only had 47 minutes to do research each day. And so one day, he was in these committee meetings at 10 o'clock at night. It was canceled because some poor professor died of exhaustion. So he went for a walk in the countryside and he decided to steal an apple from a local apple orchard. This whole business of an apple falling on his head did not occur. Okay? So he climbed into the apple orchard, which at the time would have been punishable by death. He stole an apple, he ate the apple, but he come up with this idea of universal gravity. So the next day he was telling one of his professor friends, who also doesn't teach, about this idea, and they say, you must go to the court of England and you must present to the king's scientist. He shows up there and he starts presenting this thing. First he has to make all these wild promises. He has never met or talked to a Russian. Why in the 1600s a Russian was so terrible, I don't know. Anyways, had a long list of things, and eventually he could present his idea on universal gravity. And in the end, he decided, he was looking at the audience, as I am now, and he saw people. Remember, the court of England would have not been scientists. They would have been business people. They would have been, people selling things, court jester. They would have been all sorts of entertainers, everything. And so he decided to give an example. He said, suppose an apple falls from the tree. As he said it, the Apple Growers Association of England jumps up and says, have you found a way to make a better apple? Something to that effect. And the whole room descended into bedlam, talking about how the apple falling from the tree could be softened, because if you could affect gravity and so on and so on, the apple would not be bruised and so on. And he just gave up and he left. The next day he got given a trunk in quadruplicate. Everything was done in quadruplicate in the 1600s. And he had to fill it out, and the Apple Growers Society of England paid for all of his research. So Isaac Newton did not get money from Cambridge. He got all of his money from the Apple Growers Society of England. So the apple falling on his head, forget that. But the point is that quantum leaps of faith are not based on incremental steps a lot of times. You might get lucky, don't get me wrong, a blind squirrel sometimes finds a nut. And that will work. But you have to have the freedom to do research beyond the bounds of dogma. And in 1936, Carl Jansky met up with a group of optical astronomers who could not believe that there were such things as radio emission from the center of our galaxy, and they refused to publish. And that was probably one of the single greatest discoveries in astronomy since they found astronomy, because it meant there were other areas of the electromagnetic spectrum that you could use to do science, and you could use a free laboratory, because that's free. Looking up is free. Even in African countries and in Canada, it's all free. So that is the whole story. That's the whole story of ancient astronomy. But I don't believe in the scientific method. So please, don't give me a hard time that I don't teach scientific method. In fact, when I teach students, I try to convince them to go into banking. So I actually teach commerce most of the time, because I don't want astronomers who want to make money. I want astronomers who are passionate about astronomy. I want people that are creative. So I try to find astronomers who are good at musical instruments, they play sports, I want somebody that can imagine, that can think of things that don't exist yet. And when we build telescopes, we must design a telescope not for what we know, but what we don't know. And that is where science, and the Western world in particular, has failed in the last 50 years. We now design and build telescopes. We accept papers only if we understand what it is they're writing. If we don't understand it, they will not publish. And we will all sit here, and I've had publications, I recently sent one off, and maybe it was a bad paper, it probably was. My English is terrible, it's not my first language, okay? Don't ask what my first language is, I don't want to be rude. But anyways, the upshot of the story is that when I tried to publish my paper, no one would accept it, mostly because they decided it didn't have enough gravitas. What the hell does that mean, gravitas, you know? And what they were saying is, no one's going to cite your paper too many times, so we don't want it in our journal. But the point is that, and as I was saying to my colleague Jiwaji earlier, when you do theory versus observation, there's always a measure, there's always an error between what is leading your scientific field. What field of science do you study? Sorry? Nuclear physics. So at some point, nuclear physics was driven by the laboratory experiments. The crazy people before World War II, like the Canadian who dropped the two hemispheres together and then killed himself 3 days later from radiation poisoning. But he was a laboratory experimentalist. And theory and observation were fighting amongst each other to determine how to explain these things that they were finding. So at one point, theory was being led by observation. And then eventually theory takes over, and then it makes predictions, and then observation must catch up. Now, this journal would not publish my results because they thought not enough gravitas. But what I was trying to say is, I found a very rare object. There's only 6 in the universe, and it was only 5, and this was the 5th. Okay? So I found the 5th object in the universe, and I found that it was highly variable, which suggested that's why there's so few detected. If you do a measurement of observations, you will only see 1 or 2 at a time. But they wouldn't publish this. They thought it was unimportant because there's only 40 people in the world who would read my paper, and therefore it wouldn't get cited enough to make it a useful publication. But it doesn't make it science. It's no less science than somebody who writes a 35-page thesis on bubbles of water in a coffee cup. Anyway, so I'm not a big fan of scientific method. So remember, keep that in your heads as we do this. And what I want to say, though, is I did get a chance to work on some really interesting science projects. In particular, I got to work in the SKA project. If you don't know, SKA